Okay, let's take a look at the integral of cosine squared x dx. Now let me say this. This one's kind of weird, and you're going to need to use a trig identity. Not the one you're thinking of, not sine squared x plus cosine squared x equals 1. If you use that identity, you actually end up getting another integral where you just have now sine squared x, and you have to integrate 1, and that's no problem, but the problem is you'll have to integrate sine squared x. So that won't end up getting you anywhere. For this, you're actually going to have to use this identity, okay, that cosine squared x. That's equal to 1 plus cosine of 2x all divided by 2. So let's just make a replacement here where you see that cosine squared x, just replace it with this thing. So then this integral here becomes, this is equal to, let's fix that. So this is equal to integral 1 plus cosine of 2x all divided by 2 dx. You can break this fraction into two pieces. So you have the integral of a half, 1 over 2, like this 1 over 2. Okay, that's really nice to integrate. That's just a number. And then you also have a half as a coefficient multiplied by cosine of 2x. You can also write that as cosine of 2x all divided by 2. And then this dx right there. Now, let's go ahead and just integrate this 1/2 part straight away. So here you should get 1/2 times x, and then now what's left is integrating this part right there. We can even bring that 1/2 in front of this integral, and we're left with cosine of 2x dx. Now all you have to do is take this integral. You could treat that as an integral to do on the side. What would you do there? Well, you could pick u is equal to 2x. Then du is equal to 2 dx. There is not a 2 somewhere in here, so let's introduce one, okay, so that we can get an expression that has the 2 dx in it. So we can rewrite this, just copy the first part. This is x over 2 plus a half integral. Since we want that 2, let's introduce a 2 in the denominator. Then you have this cosine of 2x. Then you multiply by the 2 that's introduced. Then you have dx. Okay, now the whole point is if you cancel this 2 and this half, you get back to the original what's right there. But now the punchline is that you have this 2 dx, which is du. So we'll make that replacement in the next step. So this is now x over 2. You can actually bring out that other 1/2 right there. So this is plus 1/4 integral cosine of, and this 2x is u. Then this 2 dx is du. Okay, now we have a nice integral. We can finish this off. This is x over 2 plus 4th. What do you have to differentiate in order to get cosine of u with respect to u? Well, that's going to be sine of u. Right? Differentiate sine of u, and you will get cosine of u. And don't forget your plus c here. The last thing to do is to replace this u with, where is it? Right there, that 2x. So x over 2 plus 1/4 sine of 2x plus our constant c.